application of engineering techniques, sectoral interventions, and the elimination of direct threat, such as on-source pollution, are important, but they are not sufficient. We have wastewater treatment plant, we develop them and put them into place. But the issue is that how sustainable are they? How effective are they? All these are questions that need to be addressed. And some of those that have it, when they got broken down, what happened? That is all. Most of those industries, when you go, they will tell you, oh, we have either wastewater treatment plant, but when you go, you look at it, they are not functioning. So, which means they are not sustainable. So all these are factors we need to look at. And when you look at the challenge we are having, our ecosystem, over 90% or 80% of the whole wetland has been lost in the last 100 years. And we know the value of wetlands.
80%.
Wetlands.
Yeah.
Yes.
In Nigeria or you are looking at
Globally.
Globally.
Both in Nigeria and outside. 90% of the wetlands has been lost. Then when we also look at the biodiversity is also being lost. Many. And that is why we also have a sustainable development goal targeting biodiversity alone because of these issues. So the development of solutions to the global challenges need to be based on transdisciplinary various areas. We can't say, oh, it is one. Oh, it is only engineering. No. There are other disciplines as well that can also play a very vital role. One of it has just been highlighted by our chairman, the law, the right. Is that clear? It also plays a very important role in our management. So, recognizing cultural and time-dependent dimensions of human being, mitigating natural and man-made induced disasters, and fostering sustainable development of our cities. So all these are things that are needed. So there is need for what? An integrative science. And this is where the paradigm shift came in. This is where the emergence of ecohydrology constitutes a new dimension and became relevant in water resources management. Ecohydrology aims to find solutions rather than focusing exclusively on technical issues. Better response to sustainable water resource policies and promote social development with stakeholders' participation. That you cannot achieve. Stakeholders must be involved. And I would also advise here, yes, we have industries here and there, but I would advise our chairman as we move along with the Ecohydrology, we need to bring them on board. They are also stakeholders because they utilize the resources of the Ecohydrology. So let's bring them on board. Advocate and continue to advocate until they come on board. We really need them to be part of the journey. So, and that will make integrated water resources management more successful and effective. Now, understanding ecohydrology, the question I will pose, what is ecohydrology? Do we have a visualization of what ecohydrology is all about? Can somebody throw more light on this?
Well, from the keywords,
Yeah.
eco depicts economy, hydrology has to do with the water system.
Okay.
So I will coin them together.
Okay. Economic
Water of water resources.
Good. Any other contrary view? Oh, we are all in line with what he has said. We are all in line with what he has said. Okay? Okay? Okay.
Ecological.
Okay. Okay. Eco stands for ecological. Okay. So that is the little change. The eco is all about the ecological perspective, while the hydrology remains the hydrology. So that is the.
I also want to say that you can also look at this. It's not different from his,
Okay.
but talking about the ecosystem.
Yes,
Taking water bodies as an ecosystem on
System.
itself.
Exactly.
So that the components interacting with each other.
Yes.
Once you have an ecosystem that there is no living thing inside, that it's not, that means it's not safe.
Yeah.
Once it's not safe for those living organisms,
Yeah.
that means it's not safe for us. That
Yes,
means there's no life, it is dead. So when you talk about ecohydrology, I'm talking about water bodies, looking at it as an ecosystem of its own.
Please, fantastic. She has briefly explained the whole thing.
It's not conducive for you. For the apartment.
Yes, it's not.
It is very good for man.
Yes, that is it.
The lecturer.
So basically that is what ecohydrology is. Ecohydrology is a sub-discipline of hydrology that focuses on ecological processes occurring within the hydrological cycle and strives to utilize such processes to enhance environmental sustainability and harmonize societal goals. So it's based on the ecological processes, looking at the ecosystem as I said, and also the hydrology. These two things goes hand in hand. Is that clear? One shaping the other. Is that clear? So that is what ecohydrology is all about. EH, as it is being simply called, is an emerging integrative science that uses ecosystem properties as tool to meet water and related resources management goals. So it utilizes that ecosystem properties to be able to achieve water and environmental and other issues as well. So this is basically what ecohydrology is all about. Now, what are the concepts of ecohydrology? Ecohydrology utilizes what we call a dual regulation principle. And how do what is the dual system? Biota, just as he has said, biota are the living entities within an ecosystem. They regulate hydrology, and hydrology also regulates them, vice versa. Do you understand? Now, let me give us a typical example. Now, when we look at our water cycle, is that clear? We have water evaporating from the surface, but we also have water as a result of transpiration of the plant moving. And that is why we discovered that where you have forested areas, they have more rainfall than the dry land. Do you see the logic? So these are entities that circulate in dual regulation. Biota, shaping hydrology, and where you have a lot of water, you have a lot of biota. You see plants, you see organisms. So this dual regulation is what it encapsulates in ecohydrology. I hope we are understanding the concept. So it works on this. The dual regulation is biota by altering hydrology and regulating hydrology by shaping biota. So all these are the factors. Then harmonization, ecohydrology measures within the hydrological infrastructure. Also, ecohydrology utilizes some of the infrastructures that are designed by engineers, by technicians, and so on, to be able to what? To shape biota, and also biota to shape hydrology. Then integration, it integrates various regulations acting in synergy with the already synthesized biota and hydrology to manage water resources entity. So this is the concept and principle of operation of ecohydrology. Now let's look at the principles. Ecohydrology is working on three basic principles. One of it is what we call the hydrological principle. The second one is the ecological principle. And the third one is the ecotechnological principle. And we are going to look at each and every one of these. Now, the first one, the hydrological principle. The regulation of hydrological parameters in an ecosystem or catchment can be manipulated in order to control biological processes. And I can give you a typical example where you have, for example, erosion and so on. By the time you have more plants there, it stabilizes the soil and erosion will find it difficult. So this is a simple technique using nature. It doesn't require any conventional techniques. So this now will modify that kind of system. Then next, we have the quantification and integration of hydrological and biological processes at a basin scale is based on the assumption that abiotic factors are of primary importance and become stable and predictable when biotic interaction start to manifest. Just as she has said, if you don't have living organisms interacting with themselves, that place is already dead. So we needed the biota. Their processes and activities shape one another to be able to stabilize the system. And this is the kind of management approach that we needed. The second principle is the ecological principle. Shaping of the biological structure of an ecosystem in a catchment can be achieved by regulating hydrological processes. If you plant your grass, as long as you keep on watering it, is that clear? The grass will survive. If you don't water it, it will dry and die. So that hydrology also needs to come into place. Is that clear? To now shape the biota and then make it to thrive. I hope we are understanding the concept. So the ecological principle is based on the assumption that under intensive global changes, it is not enough to protect the ecosystem against increasing human population and aspiration, but it is necessary to regulate the ecosystem structure and processes towards increasing their carrying capacity. For a river, river in its natural self has a self-purification ability. As long as it is flowing, it has that self-purifying ability. But when you keep on polluting it beyond its carrying capacity, what happens? So that means, yes, we need to go back and see, okay, how do we now improve the carrying capacity of that river so that the river, whatever pollution that is coming, it will be able to accommodate it and self-purify itself. So this is also needed. So once the ecosystem carrying capacity has been overloaded, we need to see a way of reinforcing them so that they come back to life and be active. So this is needed in our system to be able to do that. Then the next, but the last principle is eco-technological. What types of regulation, that is the hydrological, the ecological, at a catchment scale in a synergistic way can be utilized to achieve sustainable management of freshwater resources. One, the use of ecosystem properties as management tool based on the first and second principles, and then the dual regulation shaping biota and hydrology, and then the integration at basin level to achieve a lot of things. We can even utilize the dams. The dams, yes, it's a technological system, but we can also utilize it to shape biota. So, harmonization of eco-hydrological measures with the necessary hydro-technological solutions like dams, irrigation system, sewage treatment plant, and so on. We can utilize them to be able to shape the hydrological system, to be able to shape biota. You understand? So this can also be achieved. For example, where we have a wastewater treatment plant that is not active or is not able to purify the water to the level we want it, we can now supplement with a constructed wetland. And this is made of what? Biological entities that will absorb those pollutants from it and make it more safer for us to utilize. So this is the kind of system we are looking at under this principle. Okay, so now, how does eco-hydrology work? Based on the dual regulation. You can see within the hydrology, this is a riverine course, and within the riverine course, you have a lot of things happening. You have precipitation, you have evaporation, you have infiltration, and so on. All these are happening within the basin. Is that clear? And at its flow, it is interacting with different ecosystems. Is that clear? Both aquatic and land and so on. Then the next one, you also have the ecological. Now, the parties of ecological ecosystem working on their own and trying to purify. And part of them, you discover that some are trapping nutrient and absorbing it. Is that clear? Some are trapping sediment cleaning the water, and so on. So as long as the water is passing along the line, you have various ecosystems acting on it and making it work to purify the water. And that is why, as long as the water is flowing within those ecosystems, you are having that self-purification. So last is also you are having a lot of now using the hydrotechnological principle. You are having like planting some woodland, is that clear? To assist in stabilizing the ecosystem. Also using like small pond to retain the water. Also using like buffer strip, what we call the ecotones, to now trap and guide and protect the bordering areas of the water body and so on. We also have what we call the constructed wetland, where industries are discharging. In between, you can put a constructed wetland that the wastewater from the industry must have to pass through the wetland, being treated before it moves into the river. By so doing, you are now protecting the river. Is that clear? And purifying the water before it goes out. So all these are systems that you can utilize to be able to manage out. And they are simple, not complex, that the way we have wastewater treatment plant being designed and constructed. Is that clear? So these are some of the systems. So this is how EH works. And EH works just like I've said. Once the carrying capacity of the ecosystem goes down,